the library of functions. Before we do that, so tomorrow on Wednesday, section 3.5 is due. It's actually a 2-day lecture during the normal class period. So it's a longer assignment, so just don't think it's a shorter assignment. It's actually 2 sections rolled into one. Then on Saturday, you have section 3.6, which we'll talk about on Thursday. And then you have your second review to date, which is due by the Gmail address. So send it to my Gmail. That's due on Saturday. That's your second review to date, just helping us get ready for that final exam. And then on Sunday, you have another quiz. That's quiz 4. So that's halfway through the quizzes. Yay! And your second application discussion in Blackboard. So you need to be picking out a problem from the list of problems that are there. They're on the discussion itself. And then work one through and then post your solution to it. So that's what our this week is looking like. Oh, and I forgot, the other thing to remind you about is exam 2 is ready to go on ProctorU. So you can go ahead and schedule it. So it's ready to go. It opens Friday the 19th. So you can schedule it sometimes between Friday the 19th and Sunday the 21st. So, but it's all there. It's set up. We shouldn't have any issues this time. I was really excited that it's active. No hitches in the problems at all. So that's just looking a little bit ahead until next week. So just a reminder that if you wait to schedule it within that 72-hour window ahead, then of this due date or when you're scheduling it, they will charge you this time. So, okay, so a reminder of what we did on 3.4 last week. So just our toolbox functions. And it's because we're going to need them today. So let's go through and make sure everybody kind of remembers them. So we did several of them. They're not in any order. Let's do the constant function. Let's do f of x. And I'll pick a specific number. Let's do f of x equals 4. So what does the graph of that function look like? And this is where I need your feedback. So
horizontal line.
Yep, it's a horizontal line up there at 4. Beautiful. So horizontal line at 4. Great. Okay, and then we have our identity function, which is just f of x equals x. Does anybody want to jump in on what that one looks like?
Just a vertical line?
No, a vertical line is not a function because it would fail the vertical line test.
Oh, yeah.
So this
Is
guy,
one that goes to the origin?
Yep. And what kind of slope does it have? It goes up one and over one?
Over one.
Yeah. So it cuts through at like a 45-degree angle. It bisects angle quadrant 1 and quadrant 3. And again, it's how we fold things over the origin, believe it or not. Okay, those are, for some reason, they're tricky too. What about f of x equals x squared? So f of x equals x squared. What does that graph look like? What's its shape called?
Parabola.
Yep. And the bottom of our parabola, which would be its minimum, is at the origin. That actually has a name. We didn't give it a name last week, but we can give it a name today. It's called the vertex. It is the only shape that has a vertex. So just as a comment, when we talk about things, it's the only shape that we do that has something called a vertex. And in this case, it's the minimum of it. We also did f of x equals x cubed. So do you remember what we called that shape?
S-shaped.
Yep, that's an S shape. It looks like this. So again, that's our S shape. Yeah. Now, the point at the origin has a name. It's called a point of inflection. We'll bring that back in much later on. But it's where the concavity changes or the curvature changes. You can see it's kind of concave down here and concave up here. So it's got a specific name too, but it doesn't, not called a vertex or anything. So we're just going to call it the middle. And then we went on to the roots. So what about the square root of x? What does that graph look like? So the square root of x.
A V shape.
Ooh, that's the absolute value function. So let's do that one next. F of x equals the absolute value of x. That's our V shape. So that's the one that looks like this. It's kind of easy to tie the value with the V. So the square root of x looks like a half a parabola. So it does something like this. And again, we plotted points. So we have points for all of these. And then another one that we do is f of x is equal to the cubed root of x And that's a sideways S. I'm watching the board to see how far down I am. So that's the S that's in quadrant 1 and quadrant 3 and looks like this. And again, you could plot points, plug in a 0, get a 0, plug in a 1, cube root of 1 is 1. So. And then the last one, which I think is the one that's a little hard for everybody because we just haven't used it much yet, that's the 1 over x. It's called the reciprocal function. That's the one that I call a bow tie. So it looks something like this. Okay. And those are our 8 toolbox functions. They're the ones that you need to know pretty much by memory what the general shape is, because what we're going to do today is transform them. And what that means is we're going to move them around the axis. So, okay, has everybody got them? Keep practicing them. If we were meeting face to face, I'd be giving you quick pop quizzes every day until I'm convinced you know them. So that's how important they are. So today what we're going to do is take these toolbox functions and shift them. So section 3.5 is the transformation of functions. And every time I do this section, I've got the theme from the Transformers in the back of my mind because we're transforming things. So what we're going to do is we're going to use as our base function or our parent function. We're going to use f of x equals x squared. Okay. So what I want to do is I want to use that graph, and then we're going to graph several of them, and it takes a while to get through this, but I think you'll follow it okay. We're going to do f of x is equal to x squared plus 1. So I still have the same parent function of a parabola, but what I've done is I've added a plus 1, and I've added the plus 1 after the square root. So what we're going to notice that this plus 1 is outside of the x squared. And I'm just going to use the word outside because it just makes the most sense to us. It may not look like it's outside, but it's outside. So normally what I would have a class do is just do this on their graphing calculator because it's just quicker. We don't need to plot points on all of them. So if you have your graphing calculator, does everybody know how to use their graphing calculator? How to type stuff into it in order to get a graph out of it?
Yeah.
Yes.
Okay. Everybody? Two of you said yes, so I'm going to assume that that's a good. So go graph this on your calculator. If you don't have your calculator, go run and get it. Find it, because you're going to need it. So I want to know what this picture looks like.
Just a parabola starting at 1.
Yep.
All y equals 1.
That's exactly it. So the vertex has been moved. It's still the same U shape. The only thing is we've moved it. So what we're going to say is that this shifts the graph up 1. So it shifts up 1. So when this plus 1 was outside, we saw that the graph was shifted up 1. Beautiful. Okay, well, let's do the same thing. And this is where I just need a lot of board space, I tell you. What we want to look at this time is f of x is equal to x squared, and we're going to do minus 3. What we're noticing this time is that that minus 3 is again outside or after the x squared. So this is outside again. So the change is outside. So then what does that minus 3 do for the picture? So again, you go back to your calculator. Instead of doing a plus 1, you're going to put a minus 3, graph it, and tell me what happens to it.
It's moved down 3.
That's exactly it. So that vertex, the point where we start our picture drawing, is now down 3. Still got the same U shape. We're not changing its shape at all. All we're doing is picking up and moving it. So in this case, we shift down 3. Beautiful. So when it was a +1 on the outside, we went up. When it was a -3 on the outside, we went down. Any problem with that? So without graphing it, can you tell me what would happen to the graph of x squared plus 5? So if I wanted to graph that without my calculator as a quick sketch, I'm going to note that the +5 is outside, and in this case, it would shift it how? What's your guess?
Up 5.
Beautiful. So because the +5 is outside, it's going to shift up 5. And it's really shifting every single point on the graph up 5, but all we really plot is that one point that makes up the vertex. So beautiful. Okay, that's on the outside. And in a minute, we'll come back and write some generalized directions. Okay. Now we're going to change where we're writing that change. So what if we have this time f of x is equal, I'm going to do x plus 1 in parentheses, and then we'll put the square. So x plus 1 in parentheses, and then the square. So it's still the parent function of x squared. So the picture is still going to look like a parabola. But what happens this time to the picture? So I'm just going to make the comment that this time the change is inside of the square. And that's what the parentheses are telling me, is that it's on the inside. So when you graph it on the calculator, what do you notice about where the parabola has been moved?
It moves left to right, or it moves left.
In this case, it's moving left. Correct. So I'm going to put the vertex over there at -1 and draw my same general U shape. So again, shape's not changing. So shift left 1 unit. Okay, well, what if we do the same thing but do an x minus 4 quantity squared? So we're going to notice again that the change is on the inside. On the inside of the function. And if you graph that on your calculator, what happened to it?
To the right 4.
Yep. So now we're over here at 4, 0. Apparently it's going to be a dyslexic day. Not a good day for that. Correct. I did the same thing over here. Nobody commented. The -1, 0. Beautiful. So we went left or to the right 4. Shift. Right 4. Okay, so before we go any further, I want to stop and summarize what's happened with these 4 graphs, just so that we're all on the same page. So right now, we know that if the change is outside, we went up or down. So we're going to shift up or down. And if it was on the inside, we went left or right. So if the change was on the outside, we went either up or down. If the change was on the inside, we went left or right. Okay, on the outside, if it was a positive, we moved it up. If it was a negative, we moved it down. So we did exactly what we think should happen, because positives are up and negatives are down. So we're going to write, do what it says. We'll say, do what the sign says. However, when we moved it to the inside, we did kind of what the opposite of what we think it does. When we had an x minus 1, we went to the right? I'm sorry, we had x minus 4, we went to the right. We had an x plus 1, we went to the left. So we're going to do the opposite of what it says, of what the sign says. Okay. So if it says plus, we normally think of plus as going to the right. We're going to go to the left, the opposite. To summarize what's going on here, right, because I've kind of got this versus going on, what we're really saying is if it's outside, it's making a change in the y direction. That's considered to be a vertical change. A vertical change. Okay, if it's on the inside, we're going to do something in the x direction. We're going to make a change in the x direction. And that would be a horizontal change. Okay. So what I tend to remember to myself is if I'm outside, it's doing something to the y. If it's inside, you're doing something to the x. So far, so good. And you may have done this before. We just may be doing it a little more in depth than you've done it before. Okay, everybody got it so far? Well, are there other changes that we can do? So in other words, in addition to moving it left or right or up or down, what else can we do? So I'm going to change my parent function this time to help us see what's going on. So this time we're going to deal with f of x is equal to the square root of x. If you remember, that's the half a parabola that opens to the right. So it looks like this. And again, the points would be 0, 0. You plug in a 1. You'd get the point 1, 1. The next point you'd plug in would be a 4. And you'd end up out here at 2. Because the square root of 4 is 2. Sorry, that's a little sloppy. Okay. What we want to do is start trying to flip this function. So what if we come in and graph f of x is equal to a negative square root of x. So a negative out in front of the square root of x. Okay, well, we just said that this guy is on the outside. So because it's on the outside, we know we have to do a change in the y direction because it's on the outside. Okay, well, what that's going to do to my picture? Well, it simply means that I'm going to take every single y value and change its sign. That's what this is saying. It's the opposite of that sign. So that's going to take all my y values and make them negative. So we still have 0, 0 because negative of 0 is 0. But the point that was at 1, 1 is now going to be down here at 1, negative 1. I'm changing the sign on the y. The second or the third point, which was at 4, 2, is now going to be down here at 4, negative 2. And again, you could just plug the numbers in. Plug in the 4, you get the square root of 4, which is 2, and it says take the opposite of that. That's why we get a negative 2. So because the negative was on the outside, we did a change in the vertical direction or in the y direction. And this looks like we just flipped it over, and that's exactly what we did. So we're going to call this a reflection over. You can use the word across. I tend to use the word over because it's more descriptive. The x-axis. Okay, now notice how subtle this is. We're changing the y values because we went over the x-axis. That's called a reflection. Well, if I can reflect this thing down, can I also reflect it left to right? Let's try that. So we're going to do f of x is equal to the square root of a negative x. So notice where the negative is this time. It is on the inside of this. So that negative is on the inside. So we know that that's a change in the x direction because it's on the inside. So instead of changing the signs on y this time, we're going to change the signs on the x's. So we have 0, 0, nothing's going to change there. What we're really going to do is, if I plug in just a 1, I can't take the square root of one, a negative 1, so I have to plug in a negative 1. So my first point is going to be over here at negative 1, 1. Think about that. That's the opposite of a negative 1 square rooted. That's the opposite of a negative 1, which is a positive 1. Square rooted is 1. And then the next point is going to be up here at 4, 2. Sorry, negative 4, 2. Because you have to change the sign on the x before you can square root it. So the graph would look something like that. And again, you can plot points. You just have to be careful about what points you're picking and plotting. So we're going to consider this to be a reflection over the y-axis. We're changing the sign on the x's, which is a reflection over the y-axis. Okay. So we've moved left, right, up, down, and we've reflected over both axes. Is there anything else we could do? Yeah, there's one more thing we can do. Is everybody good with the reflections?
Yes.
Yay. Yay. Okay, I'm going to go back to the parabola just because it's the easiest one to work with. So we're going to go back to a parent function of f of x is equal to x squared. And because I want to be specific about some points here, we're going to plot a couple more points on our parent graph. So you would have the point at 0, 0. You would also have the point at 1, 1. And then you have the point at negative 1, 1. And if you wanted, you could plug in a 2 and get a 4, and a negative 2 and get a positive 4. The last transformation that we address in our class, let's do f of x is equal to 2x squared. So 2x squared. So what I did this time is that I put a 2 in front of everything. So is that 2 inside or outside?
Inside.
Well, and so this is where we need to make sure we're understanding it. If I wanted it to be inside, I would see a set of parentheses before I see the square. And because I don't have the parentheses, this is essentially saying this is 2 times the x squared. So if I wrote the parentheses with the 2 on the inside, then it would be inside the function. But for us, that 2 is outside. And you probably haven't seen this before, so that's why it's new. So that 2 is a change on the outside. So we know it has to affect things in the y direction. So this is a change in the y values or the y direction. And we're going to do exactly what it says again. So because it says 2 times, we're going to multiply all the y values by 2. Multiply y values by 2. So I'm not going to touch the x values. I'm still going to plug in a 0. I'm going to output a 0. Nothing's going to change there. But when I plug in a 1, 1 squared is 1, and then I would multiply it by 2, and I'm going to get a 2 over here. So this is the point 1, 2. On the other side, if we plug in a negative 1 squared is a positive 1. Multiplied by the 2, again, gives me a 2. So I have negative 1, 2. So when I compare the two of them, what I should notice is that in terms of the y direction, it's been stretched. So this is what we call a vertical stretch by 2. So you're simply coming in and taking this picture and stretching it in the y direction. So, very interesting. Does that make sense? And does everybody see where those points are coming from? Okay. So we'll do another one. And unfortunately, because they keep writing all over the board, I never have enough room. You wonder why there's so many boards in front of the classrooms. This is why. Okay, still springboarding off this idea. We're going to do f of x is equal to 1/2 x squared. So 1/2 x squared. So instead of a 2 out in front, we have a 1/2 out in front. That looks interesting. Do we all agree that that 1/2 is outside?
Yes.
Okay. So what we're going to do this time, so we again know it has to be in the y direction because it's outside. Okay, 0, 0 doesn't get changed no matter what I do. But the point that was at 1, 1, what we're going to do is take our 1, we're going to square it, we get a 1, but multiply it by 1/2. So it got cut in half. So this is the point 1, 1/2. When I plot on the other side, I'm going to see the same thing happening. When I plug in a -1, I'll get a positive 1/2 as the output. So those points that were 1, 1 and -1, 1 are now down at 1, 1/2 and -1, 1/2. So instead of stretching this thing, we've compressed it. So you can a couple different words here. I like the word compress because to me it makes sense. Your book can also use the word shrink. So this is a vertical compression by 1/2. You could also use the word shrink here. To me, that grammatically just sounds awkward, but it's a vertical shrinkage by 1/2. So, and again, what you're doing is you're taking every y value and cutting it in 1/2. So, okay, the book also covers, but we've chosen to not put it into the 120 course, horizontal stretching and shrinking. It's not, you won't have it on the homework, you won't see it on the quizzes, and you won't see it in terms of the exam either. That we've left for pre-calculus. So if you take a pre-calculus class after this, and that's when you'll do your horizontal stretching and shrinking. It really belongs with the trigonometric functions, so that's why we've left it out of this course. We don't do the trig. Okay, so that is everything that we could possibly do to our transformed picture. So again, I'm going to try and summarize where we're at, just so we've all got it. So this is where we're at. So we're going to say f of x is equal to a times x minus h squared plus k. And that just came out of the blue, and I recognize that that just came out of the blue, believe me. I, again, am picking on the parabola, but this would be true for any of our parent functions. So the cube root, the reciprocal function, the absolute value function. I'm just picking on the quadratic because that's what we were dealing with. Okay, so what we have is this a, an h, and a k. So for us, we're going to write inside, and again, versus outside, outside versus inside. Okay, and we already know this, but if it's outside, it affects the y values. So we'll say changes in y. And again, that means vertically. Vertical changes. Okay, and you do what it says. Do what it says. And we said this before, but just to summarize it. And then we said just a few minutes ago that the inside was changes in x, which is horizontal changes. And you do the opposite. And I mean the opposite operation. Okay, so in terms of this specific function, what is on the outside and what is on the inside? So this a that's out in front is on the what? Outside or inside?
Out.
Out. So for this exact function, the a is on the outside. So I'm just going to list it here for now. What about that h? Is it inside or outside? So the question to yourself, is it inside the squaring or is it outside of the squaring? What do you think? Because it's inside those parentheses, I just said inside the parentheses, we're going to consider the H to be inside. So I'm going to put it over on that side. Then finally, the only other thing that we could see would be something added or subtracted after the squaring or after the set of parentheses. So then the K is going to be over here on the outside. Okay, so we put them where they belong in terms of our little analogy. Okay, so the A that's out in front actually tells me two things. It tells me where we reflect it. So the A out in front is going to tell me it's a reflection over the x-axis. That's if A is negative. It also is a stretch or a shrink. So stretch, shrink in the vertical direction. So it could be a reflection if it's a negative, and it also tells me whether I'm stretching it or shrinking it. And that's what that A that's out in front can tell us. It tells us two different things. Okay, the K at the end is simply either up or down. Okay, up or down. Okay, so moving across to the inside of what it's saying, the H that's on the inside is going to move it left or right. So left or right. And we also just need to make ourselves a comment that it's in negative on the inside. Oh, I need to figure out how I want to say this. So if the X is negative, so we'll say if negative sign on X, then we know we're going to reflect over the Y. Okay, and that summarizes everything that we just did in terms of drawing pictures. Okay. So if there's a negative sign on the X, then we know we're going to reflect it over the Y-axis. So now that we've got that down, what we're going to do is come in and describe with words how changes are done. Okay. So we're not going to graph them out. You can, but at this point, we want to try and make it a little bit easier on ourselves. We're just going to use words to do it. So, okay, everybody got the board? We're going to erase. So we want to describe in words the changes to the parent function. The changes to the parent function. So let's do, I'm going to get away from F. We're going to use g of x is equal to the square root of x plus 3 minus 2. So g of x is equal to the square root of x plus 3 and then minus 2. So you have to take a look at this. You have to decide what's on the inside and what's on the outside, and that'll drive the whole conversation. So what about this plus 3? Is it inside or outside?
In.
In. And the minus 2?
Out.
And that's all we need. Okay, so then in words, the plus 3 that's on the inside, we do the opposite of what it says to do, so we know it's going to shift the graph how?
To the left 3.
Beautiful. Shift left 3. And then the minus 2, because it's on the outside, does exactly what it says, so that's going to shift it down 2. And then from there, you could graph it, because you would just plot the single point that was at the origin. You would go left 3 units, you'd go down 2 units, and then you could draw your shape that describes it. So, nice. How about h of x is equal to a negative of x minus 1. I'm going to pick on a cube this time. plus 5. So a negative of the quantity x minus 1 cubed plus 5. So this would be the cube function, which is that S shape. Okay, we've got 3 things going on. I got a negative that's out in front, I got a minus 1 on the air, and I've got a plus 5 over here. Okay, so I just want to know whether they're inside or outside. So the minus that's out in front is
Out,
outside or in?
outside.
Beautiful. How about the minus 1 on the in? I just said it, sorry. It's on the inside. And again, that's because it's inside the parentheses and it's inside the cubing of the function. So that's why it's in. And then finally, the plus 5 is out because it happens at the end after the cubing has gone on. So the function itself is the cube, and the minus out in front and that plus 5 are on the outside. The minus 1 is on the inside. Okay, so in terms of what's going on, let's deal with the easy stuff first. Because this is on the inside, we know it's going to shift it. The opposite of minus would be to the right one. So that's this guy. Okay, this plus 5 on the outside is going to shift it up 5 because you do what it says on the outside. All we have to address is this negative out in front. And because this is a negative times something, we know it's going to be a reflection. And because it's outside, we have to change the sign on the y's. So when I think about changing the sign on my y, that tells me I'm reflecting over the x-axis. So. Okay. Now, this specific problem brings up an idea about order of operations in terms of what you would be doing. So does it matter in what order you do your shifting? It does. And you need to pay attention to what you know about order of operations. Don't we always multiply before we add or subtract? So I would actually do the reflection first. I know this thing, instead of opening up, sorry, instead of doing this, would be doing this. So this is the reflection. And at that point, I would take the point that's at 0, 0, shift it to the right one, and then go up 5. In terms of writing it, it's not a big issue, but when you actually plot it, you have to be careful about the order of operations. So again, you always multiply before you do anything else. So nice. Let's do another one. Okay, and then how about r of x is equal to 5 times the absolute value of x. So 5 times the absolute value of x. Okay. So is that 5 on the inside or the outside?
Outside.
Beautiful. Okay, and because it says 5 times and it's written out in front, and it's on the outside, all these things are coming together. We know we're going to come in and stretch this in terms of the 5 direction. We're going to multiply all our y's by 5. So this is a vertical, because it's in the y direction, vertical stretch by 5. So it would take your V shape and make it an extremely narrow one, because you're taking those points and stretching them up 5. So if you fix the bottom of this and stretch up, you can see that it would get narrower on you. So it's a vertical stretch by 5. Nice. Okay, one more, and I think we're going to call it good for today. So how about running out of letters? S of x is equal to 1 over negative x, and then plus 2. So 1 over negative x plus 2. And this is just to get that reciprocal function in, because I haven't picked on it at all. So again, that's that bow tie function that looks like this. So we've got 2 things going on. I've got this negative sign sitting here, and I've got this 2 sitting here. Okay, so the negative, was it on the inside or the outside?
Inside.
Beautiful. And plus 2? On the outside? Okay, let's deal with the out 2, because that one's easiest. So we know that this is going to shift up 2. Again, it's on the outside, it's the y direction, we do what it says. Okay, but what about that negative on the inside? So a negative on the inside tells me it's a reflection. And in this case, because it's on the inside, we need to change the sign of the x's. So it's going to take whatever is over here and move it over here. It's going to take whatever is over here and move it over here. So if I flip the x's, I can see it's a reflection across the y-axis. Reflection, or reflect over the y-axis. Yep. So it would take this piece and move it over here, and this piece and move it over here, and then everything would go up to. Again, this would actually occur first because it's a multiplication before I can add or subtract. So again, reflections always occur first. So do stretches and shrinking. So, okay, so that is the basic of what's in that section. What we're going to do tomorrow is we're going to come in and do the same thing again, but instead of dealing with the parent functions, we're going to deal with other functions. So, and actually physically move points around. Any questions on transformations? Day one.
Okay.
We're good? Woohoo! Okay, that's it. You want to get started on it as soon as possible because we're going to build on it tomorrow. So try getting started on the homework tonight if you can, please. And then we'll do more of it tomorrow. Have a great day. Enjoy it. Here in Pueblo, enjoy the rain.
You too.
You too.
Thank you, you too.